be solving problem 1462, course schedule for today. So according to the problem, we've been given n number of nodes and that n is equal to num courses. The nodes have been labeled from 0 to num courses minus 1. Apart from that, we've been given two arrays. One is of prerequisites and the other is of queries. Now the prerequisites array, it contains elements in this format. Now what this signifies is that course A is a prerequisite of course B. Now in the queries section, the elements are of this format and we have to answer the queries section going by each query. Now each query, it is u comma v. Now we have to tell if u is a prerequisite of v or not, and we have to return the answer in sort of a boolean array. Now this is one of the examples that has been given to us. So according to the example, we see in the prerequisites array we have 1 comma 0, which signifies this, that 1 is a prerequisite of 0. Now in the queries array we have two queries, query number 1 being 0 comma 1. So this returns false because 0 is not a prerequisite of 1. However, 1 comma 0 returns true because 1 is a prerequisite of 0. Now to talk about the solution, the first solution that should come to your mind is either you use BFS or DFS. Now I'll be solving this by using DFS in C++ first. So this is the function that was initially given to us, and these are the three parameters: num courses, prerequisites and queries. Now how do we solve this? The first step being we create the adjacency list. Now to create that, we run a for loop in the prerequisites array, and we have int pre, which is defined as the first element of each prerequisite that has been given to us, and task as the second element. Now 0 to 1 signifies that 0 is a prerequisite of 1. So what we do is we have pre here and we have task here. So we have this whole directed graph that we are creating here. Now the second step being we create a boolean array answer which we are going to return. Now we run another for loop, and for this for loop we call the DFS function each time for each query. So we have pre, and then we have task, and we have a visited array that we are creating, and then we are passing all these three things into the DFS function. Now coming to the DFS function, it's a very similar common DFS function that we use. We mark visited of pre as 1, and then we go through all the neighbors. If any neighbor is equal to the task, we return true. If not, out of all the neighbors, the DFS is called again, and if at any point DFS returns true, the main function returns true. If all of this is done and still we do not get any true value, we return false. Now nothing is wrong with this solution. However, this solution does give you TLE. To solve that problem, we come to memoization. So what we're going to do is we're going to use DFS again, but we have another array that is a vector of vectors, and we name it as memo. Now what we do is we save the memoization solution. So memo of u comma v, u here is pre and v is the task that was there in the previous solution. So it is initialized as -1. So we check, the first condition is if it is not equal to -1, we return the value. 1 being that u is a prerequisite for v, and 0 being u is not a prerequisite for v. Other than that, we go through the for loop as it is, we follow simple DFS, and then we return all the values. All the solution does is it deals with the time limit exceeded problem. Now the third solution being the Floyd-Warshall algorithm. Now according to this algorithm, we again initialize a vector of vectors of the Boolean format, and this is called as reachable. Now initially it has been initialized with false, that is 0 value. Now what you do is in the prerequisites array we've been given all the direct reachabilities, so we mark them as true. Now what we need to do is we also need to find out all the transitive closures. Why do we need that? We need that so that we find out all the indirect relationships also between the courses. For example, if 1 leads to 0 and 0 leads to 2, therefore 1 also leads to 2. So to find out these dependencies, we need a transitive closure. For that, we run these three for loops. The k course here being the intermediate course. For example, if I and k is true, if k and j is true, therefore I to j would also be true. Now all of this is done, and then for every query that we have present in the queries array, we just check the reachable vector and then we give the answer. The time complexity for this code is n cube because we have 3 for loops that have been running for us. The code is again available in the description for your reference. If you have any questions, please feel free to comment. Thank you so much.